Hello everyone, this is Jason from Primetime Aquatics, and in this video we're going to be doing something a little bit different. What I wanted to do today is take a look at an article that was published that I think directly relates to what we do in the aquarium fish keeping hobby. A lot of times we talk about things like acclimating fish and why pH is so important and why temperature is so important. And I think while we intuitively understand some of these things, sometimes it's nice to understand the science behind why we do things the way that we do that. And so if you like this video, if it's something you want to see more of, definitely want to hear from you in the comments section below. Thumbs up, thumbs down. We can continue to go a little bit more hardcore into the science if that's something you want to do. But this article that we see here, I wanted to highlight some of their findings so that we can be better fish keepers. And at the end of this article, we're going to talk about how their findings directly relate to what we do in the aquarium hobby and keeping our fish happy and healthy and safe. So let's go ahead and take a look at this. This is from the Journal of Fisheries Sciences. I will put a link to this article in the description below if you want to read the entire article. Like I said, what we're going to be doing here is just hitting the highlights and seeing how this applies to us as fish keepers. The title: Acceptance of Thermal and pH Shock on Red Belly Pacu in Adverse Rapid Environmental Conditions. In other words, what these researchers were trying to do is see how temperature and pH impacts fish health and how it contributes to fish stress. And this is going to directly relate to what we do in the aquarium hobby. By the way, if you want more information on how to keep fish at a proper pH and what pH means, I'm going to put that video in the upper right hand corner as well as in the description below. I will also put the video where I talk about how I acclimate fish. I'll put that in the video below as well because that has some good sciencey information as well. So let's scroll on down here. The introduction. I highlighted some of the important points that will help us understand their findings. Right in the introduction, they say when a fish is exposed to a rapid change in stress, stress will occur, resulting in a cascade of physiological and behavioral responses, and in many cases, death. And so, in other words, we've always said on this channel, and one of the, I think, good rules of thumb is we want to have stable water parameters within an acceptable range, as opposed to trying to hit an ideal water parameter. If that fluctuates too rapidly and too often, you can have serious problems with your fish. So what were they trying to do here? The tolerance level of different species to these changes in aquatic organisms helps them to survive these extreme conditions. The effective mortality level and tolerance rate related to specific organisms can vary based on their nature of its innate immune system and specific ecosystem. What I like here is they go on and talk about aquarium fish and how their research relates to the aquarium hobby. In the case of aquarium fish, tolerance towards rapid environmental changes is a positive sign where there is a high risk of rapid change in environmental conditions like pH and temperature. So what they're saying here basically is in the aquarium hobby, we do some things that are maybe not natural. The fish wouldn't experience these in a natural setting. There can be more rapid fluctuations in temperature when we're doing things like water changes or buying fish or having fish shipped. The pH can change as well when we're doing those things. And so the idea behind this research is to figure out what exactly is happening, what are the allowable limits, and what will fish tolerate. They go on to say temperature and pH and its tolerance level determination leading to behavioral changes and ultimately mortality were focused in the study. So the focus of this study was how is temperature, how is pH impacting fish. So the first thing, they're going to take a look at rapid changes in water temperature. Thermal shock has a massive impact on physiological, behavioral, and distribution patterns in aquatic organisms in an ecosystem. Now if we scroll on up, they continue. Oops, sorry, gotten a little crazy with the thing here. They talk about how fry and juvenile fish, freshwater fish, are even more susceptible to rapid changes in temperature and pH. And so often one of the questions I get is, hey, I've got these fish that are breeding and they breed and I get the fry and they don't survive. One of the things, it's not the only thing that can contribute to low fry survival, but one of the things that we should be looking at is, are we doing water changes in those tanks? And if we are, and sometimes we need to, are we rapidly changing either pH or temperature, because that can have a very negative impact on fry and especially juveniles. So rapid change in Water pH is the other thing that they looked at. And they go on to say shock due to pH fluctuation is a condition that can kill or seriously harm any aquatic animal, something that we talk about in the pH video. The role of pH in fish and other aquatic organisms is to regulate basic life-sustaining processes. How? Gas exchange and the regulation of salts. There is one of the things that they say in this introduction is there is no definite pH range within which all freshwater fishes are unharmed. What that means is normally for most freshwater fish that we keep in the hobby, roughly speaking around 6.5 to 8 is a range in which most fish will generally do okay. Maybe not optimally, but they will do okay. However, that's not a steadfast rule because there are some fish that are found in much lower pHs. There are some fish, like some of the African cichlids, that are found around a pH of 8.5. And if you go down below 7, they can do very poorly. And so they wanted to just make that clear because, they're going to be working with red belly pacu, which is pretty good right around a neutral pH. But if we were working with maybe some of the more rare epistles or ultim angels, their optimal pH would be much lower than neutral. If we're working with African cichlids, especially from the Great Lakes, their pH would be higher than neutral, somewhere around that 8.2 to 8.4. They go on to say, although it was once believed that fish could not tolerate sudden pH changes, studies conducted by a whole bunch of scientists showed that certain fish species could tolerate such rapid changes within a normal pH range. And again, that's the key. Again, that's 6.5 to 8 roughly. Once we get outside of those ranges, as we're going to see in their results, things get a little bit more, well, it turns out worse for the fish. Okay, so materials and methods. What did they do? How did they conduct their study? So basically what they did is they took these red belly pacu. The fish seeds had a standard length of approximately 3 centimeters. So that's about how large they were. And a total of 100 fish were purchased. They were randomly divided into 8 groups of 10 each for acclimatization to one group of 20. The 8 groups of 10 were maintained in a glass tank 30 by 30 by 15 centimeters in size with 10 liters of water. They go on to say the way in which the water was maintained, they dechlorinated the tap water. The hardness, the calcium carbonate was around 115 parts per million and 125 parts per million in terms of the hardness. And that's relatively average. pH was above 7. In fact, later on they're going to talk about their pH was a pH of 8. Ammonia was 1 part per million, and so that is something to consider. That would be a contributing factor to stress. And I find it interesting. One of the things that I always tell my students, as you're reading through a research article, you really should be picking apart the methods and materials to see if there's something there that could be off, something there that could contribute to the results other than what they suppose. Right here, something right away stands out, and that is the ammonia is already at 1 part per million. As we're going to see, in this experiment, the pH is a little bit higher, and in some of those cases, the water temperature is higher, and so that in and of itself could be contributing to the stress of the fish in addition to pH and water temperature. There was no nitrites, there was no nitrates. Residual chlorine was 0.2 parts per million. They filled the glass tanks, gave it proper aeration. Before releasing into the tanks, they were acclimated to a temperature of around 28 degrees Celsius, which is around 80 degrees Fahrenheit. So again, it's a little bit warmer, but it's certainly within a standard for tropical fish. Okay, they go on to say they were not fed for the next 12 hours. In other words, let's get the fish used to their new surroundings. There's no point in feeding them now. There were no signs of abnormality, so they made sure the fish were healthy. The fish were fed a feed that was roughly 34% protein and acclimated for around 10 days. So in other words, they wanted to make sure they got the fish in, they were stable, they were eating, they were keeping the water parameters stable. All right, we scroll on down. The thermal shock treatment, in other words, they were going to change the temperatures. Let's talk a little bit about how they were going to do that. For the determination of temperature tolerance level of the red belly pacu, 4 glass tanks containing 10 fishes each were equipped with, were acclimated for 10 days. All right, that was at the 28 degrees. They labeled those tanks T1, T2, T3, and T4 for temperature 1 through temperature 4. All right, so what specifically did they do? In those tanks, they basically removed that water, they replaced the water, and they went, this is all in degrees Celsius, so for those of you in Fahrenheit, we'll convert that here in a second. The assigned temperatures were 18 degrees and 23 degrees, so they went 5 degrees cooler and 10 degrees cooler Celsius. So the 18 degrees was right around 65 degrees. So that's pretty cool. The 23 degrees was right around 75 degrees Fahrenheit. The other two tanks, they went up in temperature to 33 degrees, so a +5 Celsius and then a +10 Celsius. This is getting really warm. So 33 degrees Celsius is right around 90 degrees Fahrenheit. By the time you're getting to 38, that's roughly 100 degrees Fahrenheit. So this is fairly extreme, right? So they've got this big range of temperatures from 65 degrees Fahrenheit all the way up to 100. Okay, for the pH, what did they do here? Just like with the temperature, they had 4 tanks set up, P1 through P4. They put 10 fish in each tank. Each one of those tanks represents a different pH. Once again, when we are looking at the materials and methods, there's something that stands out here. They go on to say that the pH of their water, their starting point was a pH of 8. I thought that was a very interesting thing. I'm assuming that the reason they started out with a pH of 8 is that was the natural water pH that they were getting from their tap. If I were doing this experiment, I would not have started at a pH of 8. I would have started it at a pH of 7, neutral, and then adjusted my pH values from there, because this presents some problems for them. They start with a pH of 8 and they want to go down from a pH of 8 to 7 and then 6. All right, so two of their tanks, the P1 is a pH of 6, the P2 is a pH of 7. Fine. But the problem is going to be when they go up in pH, now they've got a pH of 9 and a pH of 10. As we discussed in the live stream when we were talking about pH, and as we talk about in the pH video I have listed in the description below, it's not a change of 1 when you adjust the pH like that. It's actually a change of 10. The pH scale is logarithmic. And so when they go from a pH of 8 down to 6, every time they change that number, it's by a factor of 10. So it's actually 100 times change in the concentration of hydrogen ions. Just like when they go up from 8 to 10, that is also 100 times change. So these are very drastic changes in pH. And by the time, quite frankly, we get to a pH of 9 and certainly a pH of 10, there aren't very many freshwater aquatic organisms that are going to be able to even survive that pH. So I do think that was a fundamental flaw in the way they ran this experiment. It's fine because we can still gain useful information, but it's just not something I think I would have done. So what did they do? They have to figure out if the fish are being stressed and if they're being impacted by the changes in temperature and the changes in pH. One of the ways that they were doing this is determining how well the fish were consuming food in these different environments. So they see the feeding rate. They say the feeding rates in each treatment tank was observed. Feeding rates as a behavioral parameter was determined to denote the level of stress in fishes within an observation period of 12 hours from the time of trial. Here is another thing. I think if I were trying to run this experiment, a lot of what they're doing is somewhat subjective. And so they're looking at, okay, how much are the fish eating, which is legitimate, don't get me wrong. They're going to be looking at gill respiration rates and general fish behavior. But some of this stuff is not easy to quantify. If it were me, I would probably be trying to look for stress hormones, the gas exchange that's happening with the fish. Obviously, you can include these other things, but in terms of a really hardcore scientific experiment, this is probably lacking in the way that they obtain their information, being able to statistically analyze their results, which is not all that easy to do when you're looking at these more subjective parameters. But once again, this will still allow us to learn some things about how we keep fish. So the estimation procedure, they go on to say the behavioral differences such as fish movements, gill movements, feeding behavior, and feeding rate was observed and tabulated against the treated conditions. So again, that's what they're using to determine whether or not the fish were experiencing stress as they go through this experiment. Now we look at the results. All right, so for the temperatures, what did they learn from these different temperatures? When a shock was provided by shifting the temperature suddenly from 28 degrees, so again, right around 80 degrees Fahrenheit, down to 65 degrees and around 73 degrees, respectively, the fishes in both tanks showed similar behavioral changes with no mortality. So the decrease in the temperatures didn't kill the fish, but it did change their behaviors. It did show that they were under some stress. Again, for fish keepers, that's important for us to understand. When fish tank water goes down, things change. Like what? There was no consumption of feed even after 3 hours after the shock was applied. That's to be expected as you're lowering the temperatures. Fish are cold-blooded. They therefore are going to lower their internal body temperature. There's not going to be as much need for food, and so they stopped eating. There was no mortality in 10 hours and 24 hours after observation period, but the fishes started showing normal behavior after around 12 hours. So at least in terms of their swimming behavior and things, they started to show somewhat normal behavior even though they weren't eating at the same rate they would have been in the standard control, which was 80 degrees. Now, when you increase the temperature, fish is in the T3 and T4 tanks, so in other words, 33 and 38 degrees, so now we're 90 degrees Fahrenheit and 100 degrees Fahrenheit. Soon after the introduction to the glass tank, fishes showed loss of equilibrium, similar to what they're seeing in figure 2, which is up here. So the increase in temperature had a much more negative effect than decreasing the temperatures. Feed consumption was about 40% when fed with formulated feed after 3 hours. In other words, okay, their metabolism is speeding up. They were still able to eat. They weren't so uncomfortable that they weren't unable to eat. Signs of stress were observed in a time period of 10 hours. No further mortality was observed in 24 hours. So what they're learning here is that the increase in temperature, again, 90, 100 degrees, this is pretty extreme. There aren't a lot of fish that would really do well in those conditions. Okay, so we scroll on up to the effect of pH shock. This is a little bit different. Again, we've already pointed out some of the fundamental flaws, I think, of the study, but we can still learn some things. And so the pH of 6, fishes were suddenly aggregated towards the corner of the tank in that particular pH, since the pH was slightly acidic. This behavior extended for more than 3 hours. There was no feed consumption observed after 3 hours. Fishes were heavily stressed in the P1. 20% mortality occurred within 5 hours. This is important for us to understand. We talk about this in the fish acclimation video, that when there are drastic changes in pH, this can negatively impact fish health. In the P2 tank, the pH was close to neutral. So we went from a pH of 8, which is relatively high, down to a pH of 7, which is neutral. There was no extreme behavioral changes and no mortality occurred in 12 hours of total observation, except some slight distress at the time of transfer. Feed consumption was up to 90%. So in other words, it wasn't that big of a change. These fish would probably normally be right around between a pH of 7 and a pH of 8. So we wouldn't really expect any major issues. But when we go up in pH, again, these are fairly extreme. After 3 hours in the P3 tank, that was the pH of 9. So the behavioral changes went back to normal after 3 hours. Feeding rate was still lowered to 20%. 40% mortality occurred within 10 hours of observation because, again, a pH of 9 is relatively high. We get that question from time to time. Hey, I've got well water. My pH is close to 9. What kind of fish can I keep in there? And again, it can be very difficult to keep fish in a pH that high. By the time we get to the pH of 10, this is something where I'm not aware of any specific species that does well in a pH of 10 just off the top of my head. So the P4, pH of 10, fish started trying to jump out of the water, high mucus secretions, acute mortality of 100% was observed in a period of less than 15 minutes. So again, this is extreme. This table here shows us their results and it kind of summarizes them for us, most of which we've already covered. So I'm not going to go into this in any amount of detail, but it is here. Again, the article is linked in the description below if you want some more information, and you can look a little bit more closely at the results. Okay, so what does this experiment tell us? They go through and they kind of summarize their results, and I highlight some important things. But you know what? I think it's more important for us to, the discussion really needs to center around how does this impact us as fish keepers? And I think the first thing when it comes to temperature, what we learn is an increase in temperature, a dramatic increase in temperature, is going to be immediately more dangerous than a decrease in temperature for fish. And so in this experiment, when they went up to 90 or 100 degrees, that started wiping out fish relatively quickly. When they went down in temperature, they stopped eating, became less active. But if we were to increase that temperature slowly and get them back to optimal, there's a chance those fish will probably survive. We also learn that the pH, when it goes up out of that comfortable range, the fish are in big trouble. So what does that mean for us as fish keepers? It means what we always say, a stable pH within an acceptable range is much more important than trying to reach an ideal pH and having it fluctuate. When we're using chemicals like buffering salts or pH up or pH down, or RO water where we could drastically change the pH in a short period of time, even though we're getting close to maybe an ideal. If we change it too fast, the fish can have big problems surviving that. So we want to be very careful of that. And that also includes when we're acclimating fish. And so, for instance, if we're getting wild caught fish and they were found in an environment where the pH might have been down in the 5s, and once you get them in a bag and you ship them for 24 to 48 hours, that pH might actually go down into the upper 4s. We get them back and we say, you know what? I read somewhere that these fish might do well in a pH of 6.5. My pH is close to that. It's a 6.8. And all of a sudden, you take that fish out of a bag at a pH that could have been 4.8, maybe 5.0, and put them in a tank that's 6.5 to 6.8. That is a big time change, and you can wind up stressing out fish and losing them. Likewise, if you've got fish that are supposed to be at a pH of 8.2 to 8.4, like some of the African cichlids, and they wind up in a bag getting shipped where maybe they came from neutral water, and that pH has gone down because they've been in a bag, and now they're at a 6.8, let's say, that in and of itself can cause a lot of stress. And then you put them back in the optimal pH, but they went from neutral to slightly acidic to your ideal pH, and then, wow, I lost these fish, but I don't understand what happened because I was doing everything correctly. And the moral of the story is, like we always say, and I've said it a couple times already, let's shoot for a stable pH that's within an acceptable range, and in most cases, that's going to be somewhere above 6.5 and often below 8 for most tropical fish. Obviously, do your homework because some will require a pH that's much lower than that, or somewhat lower than that. Some fish, like some of the African cichlids, require a pH that's a little bit higher. So again, just wanted to bring you a little bit of science and why we do the things that we do. If this is something you want to see more of, leave that down in the comments section below, because I've got some other research articles that we could certainly go over that I think will help us become better fish keepers. If you want to see more on pH, check out the video in the upper right-hand corner. If you want to see how we acclimate our fish, check out that video in the lower right-hand corner, and we'll see you in the next one.